The cosmos is not just out there, it is also within us. We are made of star dust. Carl Sagan. The Andromeda Galaxy, also known as M31, is our closest galactic neighbor. Located approximately 2.5 million light-years from Earth, it looms in the night sky as a silent testament to the grandeur of the cosmos. Carl Sagan, the celebrated astronomer and science communicator, often reminded us that we are star stuff, born from the very elements forged in stellar furnaces. In this context, the Andromeda Galaxy becomes a symbol of our profound connection to the vastness of the universe. Its billions of stars, planets, and nebulae represent an unending source of wonder and inspiration. Long before Sagan shared the mysteries of the cosmos with millions, there was Nicholas Copernicus, the man who revolutionized our understanding of the heavens. His heliocentric model of the solar system marked the beginning of a new era in astronomy, helping humanity understand that Earth is but one planet among many, orbiting the Sun. If Copernicus could have seen Andromeda as we do today, he would likely have been awestruck by the scale of the universe. Andromeda contains roughly 1 trillion stars, each potentially hosting planetary systems of its own. We now know that the Andromeda Galaxy and our Milky Way are on a collision course. In 4 to 5 billion years, they will merge into a single, massive galaxy, a cosmic event already named Milkomeda. This celestial dance is a reminder of the dynamic, ever-changing nature of the universe and our place within it. Sagan once remarked that when we gaze at the stars, we are not just looking into the past, we are glimpsing eternity. The Andromeda Galaxy is more than a neighbor in space, it is a mirror reflecting some of our deepest questions. Who are we? Where did we come from? Where are we going? And perhaps, on a quiet evening, as we look up at the faint glow of Andromeda in the night sky, we can feel the legacy of Copernicus and Sagan, inviting us to continue exploring and marveling at the infinite cosmos. The Andromeda Galaxy, also known as Messier 31, is the closest large galaxy to our Milky Way and one of the most studied objects in the cosmos. Spanning over 220,000 light-years in diameter and containing roughly 1 trillion stars, Andromeda offers a glimpse into the complex and dynamic nature of galaxies. Its faint, milky light has captivated astronomers for centuries, from ancient skywatchers to modern scientists equipped with powerful telescopes. Carl Sagan, a visionary astronomer, poet of science, and advocate for humanity's exploration of the cosmos, often spoke of the interconnectedness of all things. To him, Andromeda was not just a distant collection of stars, but a reminder of the sheer scale of the universe and humanity's place within it. He marveled at the idea that the light from Andromeda's stars takes over 2 million years to reach Earth. Each photon captured by our telescopes today began its journey when early human ancestors were just beginning to walk upright on the plains of Africa. Nicholas Copernicus, centuries earlier, laid the intellectual groundwork for such insights. His revolutionary model of the solar system placed the Sun, not the Earth, at the center, fundamentally altering our understanding of the universe. Though Copernicus lived in an era before telescopes, his work was a crucial first step towards seeing the cosmos as it truly is, vast, dynamic, and humbling. If Copernicus could glimpse Andromeda through today's technology, he might have felt vindicated in his belief that the universe is far greater and more intricate than humanity had once imagined. Modern astronomy reveals that Andromeda and the Milky Way are not isolated islands in space. They are part of a larger gravitational network known as the Local Group, a collection of more than 50 galaxies bound together by the invisible force of gravity. Andromeda's immense mass and its proximity to the Milky Way make it a subject of intense study. Astronomers have discovered that both galaxies are on a collision course, moving toward each other at a speed of about 110 kilometers per second. In approximately 4 to 5 billion years, this cosmic encounter will culminate in a spectacular galactic merger. The resulting structure, often called Andromeda, will not be a violent collision as we might imagine. Instead, it will be a slow, graceful dance of stars and gas, reshaping the galaxies into a new, elliptical form. For the inhabitants of Earth, if humanity or its successors still exist by then, the night sky will transform, filled with breathtaking displays of light and energy. Andromeda also challenges our understanding of the universe's evolution. Through the study of its structure, scientists have uncovered evidence of past mergers with smaller galaxies, leaving behind faint streams of stars and clusters that trace the remnants of these interactions. These stellar fossils tell a story of cosmic history written over billions of years, offering clues about the formation and growth of galaxies like our own. In his iconic series Cosmos, Carl Sagan once remarked, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." When we gaze at Andromeda, we are not just observing another galaxy, we are engaging with an extension of the same universe that gave rise to us. The atoms in our bodies, forged in the hearts of ancient stars, resonate with the distant light of Andromeda, bridging the vast gulf of space and time. The Andromeda Galaxy, with its uncountable stars and the mysteries it holds, reminds us that our journey of discovery is far from over. It speaks to the curiosity that drove Copernicus to challenge the assumptions of his time and inspired Sagan to reach for the stars. Through its light, Andromeda invites us to dream of other worlds, ponder the possibilities of life beyond our own, and strive to understand the intricate fabric of the cosmos. As we continue to study Andromeda, we are reminded of the duality of our existence, insignificant in the grand scale of the universe, yet capable of reaching out to the stars, guided by a thirst for knowledge and wonder. It is this spirit that links the legacies of Copernicus and Sagan, a shared belief that the universe is not only a subject of study but a source of endless inspiration, waiting to be explored. The Andromeda Galaxy, with its sprawling arms and faint yet distinct glow, has captivated human curiosity for millennia. Early civilizations gazed upon it without understanding its true nature, mistaking it for a faint star or a small cluster of distant lights. It wasn't until 964 CE that the Persian astronomer Abd al-Rahman al-Sufi first documented it in his Book of Fixed Stars, describing it as a small cloud. Little did he know that this cloud was not just a part of our own Milky Way, but an entirely separate galaxy, home to 1 trillion stars and countless planetary systems. The realization that Andromeda was a galaxy beyond our own didn't come until the 20th century, after centuries of scientific progress had set the stage for its discovery. Nicholas Copernicus, in the 16th century, initiated this transformation of thought by proposing that the Earth and planets orbited the Sun. This shift in perspective fundamentally changed how we viewed the cosmos, opening the door for later astronomers to question the boundaries of our universe. In the early 20th century, astronomer Edwin Hubble provided the definitive proof that Andromeda was not a nebula within our galaxy, as previously thought, but an entirely separate galaxy, located millions of light-years away. This discovery, made using the powerful telescopes of his time, expanded the known universe by orders of magnitude. Suddenly, the cosmos was not a singular entity centered around the Milky Way but an expansive collection of galaxies, each with its own unique story to tell. For Carl Sagan, Andromeda represented a profound opportunity to connect humanity to the larger universe. In his seminal work Cosmos, A Personal Voyage, Sagan described galaxies like Andromeda as islands of stars scattered across the vast, dark ocean of space. He emphasized that the light we see from Andromeda today began its journey long before humans had even evolved. That light carries with it a story, a snapshot of the galaxy as it existed over 2.5 million years ago. For Sagan, this realization underscored the unity of time and space, linking us to events that unfolded long before the rise of civilization. As we study Andromeda today, we uncover layers of complexity that challenge our understanding of how galaxies form and evolve. Astronomers have identified massive black holes at the core of Andromeda, similar to the one at the center of the Milky Way. These supermassive black holes act as anchors, their immense gravitational pull influencing the movement of stars and gas within the galaxy. Surrounding them, a vibrant ecosystem of star-forming regions and ancient stellar populations tells a tale of creation and destruction, of galaxies merging and reforming over billions of years. Andromeda also contains a wealth of star clusters, remnants of smaller galaxies it absorbed during its long history. These clusters, such as the famous globular cluster G1, are among the oldest structures in the universe, offering a glimpse into the early days of galactic formation. By studying these ancient systems, scientists pieced together the story of Andromeda's past and, by extension, the story of our universe's growth and change. But Andromeda is not just an object of scientific study. It has become a cultural icon, inspiring art, literature, and philosophical reflection. Its name, derived from Greek mythology, ties it to the story of the princess Andromeda, who was saved by the hero Perseus from a sea monster. This mythological connection adds a layer of human meaning to the galaxy, linking the infinite cosmos to the stories we tell here on Earth. Looking forward, Andromeda holds the promise of an extraordinary future for the Milky Way and humanity. The impending merger of our two galaxies will be a transformative event, reshaping the local universe. Although this process will take billions of years to complete, the initial stages will create dazzling displays of stellar interaction. Stars from both galaxies will be flung into new orbits, and vast regions of interstellar gas will collide, igniting bursts of star formation. For any future inhabitants of Earth, or perhaps distant descendants of humanity, the night sky will be dominated by Andromeda's glowing structure, gradually blending with the Milky Way. This collision, far from being a destructive event, is a testament to the resilience and creativity of the cosmos. From the chaos of this merger will emerge a new galaxy, a continuation of the story that began with the formation of Andromeda and the Milky Way billions of years ago. It is a reminder that the universe is in constant motion, an ever-evolving dance of matter and energy that transcends the scale of human lifetimes. As Carl Sagan once said, "Somewhere, something incredible is waiting to be known." The Andromeda galaxy exemplifies this truth. It beckons us to look beyond the boundaries of our solar system, to embrace the unknown, and to continue the quest for understanding that began with Copernicus and has been carried forward by generations of scientists. Andromeda is not just a galaxy, it is a symbol of our place in the universe, a reminder that while we are small, our curiosity and imagination are boundless. The Andromeda galaxy continues to captivate not only scientists but also dreamers, philosophers, and storytellers. Its vastness challenges our ability to comprehend scale, while its proximity to Earth offers an unparalleled opportunity to study a galaxy similar to our own. Though it lies 2.5 million light-years away, Andromeda is so massive and bright that it can be seen with the naked eye from a dark sky. For ancient humans, this faint, cloudy smear in the heavens may have evoked wonder and mystery, a reminder of forces beyond their understanding. Today, that same faint light speaks to us in more profound terms, a direct link to a galaxy whose light began traveling to Earth before human civilization began. Andromeda's structure, like that of the Milky Way, is spiral-shaped, with long, sweeping arms filled with stars, gas, and dust. These arms spiral outward from a bright, dense core where a supermassive black hole resides. The black hole at the center of Andromeda is believed to be about 100 million times the mass of our Sun, significantly larger than the one at the heart of the Milky Way. Around this gravitational behemoth orbits a bustling array of stars and dense star clusters, many of them relics from Andromeda's turbulent past. This galaxy has not always been as serene as it appears from our vantage point. It has grown over billions of years by consuming smaller galaxies that strayed too close, tearing them apart and absorbing their stars. Astronomers have identified streams of stars and clusters that trace the remnants of these cosmic collisions. These remnants tell a story of survival and growth, revealing how Andromeda has evolved into the massive galaxy we see today. One of Andromeda's most fascinating features is its halo, an immense, nearly invisible cloud of hot, ionized gas that stretches over 1 million light-years into space. This halo is so vast that it overlaps with the halo of the Milky Way, creating a region of shared gravitational influence between the two galaxies. Recent studies using the Hubble Space Telescope suggest that this halo contains clues about the galaxy's history, including evidence of past interactions and mergers. Understanding this halo is critical for unraveling the processes that shape galaxies over time. The future of Andromeda is no less dramatic than its past. Its impending collision with the Milky Way is one of the most significant events in the history of our local group, the cluster of galaxies that includes Andromeda, the Milky Way, and dozens of smaller galaxies. This collision will not happen for another 4 to 5 billion years, but astronomers have already modeled the event in stunning detail. Using computer simulations, they have predicted how the two galaxies will interact, their stars mingling like grains of sand in a vast, cosmic tide. Despite the enormous scale of this event, the vast distances between individual stars mean that direct collisions between them are unlikely. Instead, the galaxy's gravitational forces will reshape them, creating streams of stars and gas and igniting bursts of new star formation. Eventually, after billions of years of interaction, the Milky Way and Andromeda will settle into a single, elliptical galaxy. This new structure will be unlike anything we see today, a testament to the dynamic nature of the cosmos. For any observers living in the far future, the night sky will be unrecognizable, dominated by the glowing remnants of the merger. The view will be a stark reminder of the passage of time and the continuous evolution of the universe. Carl Sagan's reflections on the cosmos often emphasized the interconnectedness of all things. To Sagan, the Andromeda galaxy was not just a distant object to be studied, it was part of the same universe that created us. He reminded us that the atoms in our bodies were forged in the hearts of ancient stars, stars like those that populate Andromeda. In this sense, Andromeda is not just a neighbor, it is a kindred structure, a reflection of our own galaxy and of the processes that created life on Earth. Nicholas Copernicus, had he lived to see this cosmic vision, might have marveled at how far humanity has come in understanding the universe. His revolutionary heliocentric model, placing the Sun at the center of the solar system, was the first step in a journey that has led us to the realization that we are part of a much larger story. The Andromeda galaxy, with its trillion stars and countless planetary systems, is a reminder that our solar system is but one of many, and our Milky Way is just one of billions of galaxies. The study of Andromeda is not merely an exercise in astronomy, it is a profound exploration of our origins and our future. As scientists probe deeper into its structure, they uncover clues about the nature of dark matter, the mysterious substance that makes up most of the universe's mass. Andromeda's rotation and gravitational influence provide a unique laboratory for studying this elusive phenomenon, bringing us closer to understanding the fundamental forces that shape the cosmos. Beyond the science, Andromeda inspires us to dream of possibilities. Could there be life within its countless solar systems? What stories would those worlds have to tell? As we gaze at the faint light of Andromeda in the night sky, we are reminded of the unyielding human desire to explore, to seek answers, and to connect with the universe that surrounds us. The Andromeda Galaxy, in all its complexity and beauty, is a testament to the resilience and creativity of the cosmos. It is a reminder that while our lives are brief, they are part of a much larger story, a story written in the stars, stretching across time and space. Through Andromeda, we find not only a neighbor but also a guide, leading us toward a deeper understanding of our universe and ourselves. The Andromeda Galaxy stands as a symbol of humanity's quest for knowledge and the enduring mysteries of the cosmos. To explore Andromeda is to confront the unimaginable scale of the universe, a galaxy so vast that its light takes millions of years to reach us, yet close enough that it serves as a window into the life and evolution of galaxies. In its immensity, Andromeda both humbles us and sparks our imagination, embodying the tension between our insignificance and our potential for greatness. When we look at Andromeda, we see a galaxy teeming with activity. Its spiral arms are filled with stars in every stage of their life cycle, from newborns emerging in brilliant star-forming regions to ancient stars nearing the end of their existence. These arms, glowing faintly with the light of billions of suns, spiral outward from a central bulge dominated by old, red stars and the colossal gravitational force of a supermassive black hole. This black hole, at the galaxy's core, exerts such an immense pull that it influences the orbits of stars tens of thousands of light-years away. However, Andromeda is not merely a collection of stars and gas, it is a living, evolving structure shaped by cosmic interactions and collisions. It has absorbed numerous smaller galaxies throughout its history, each merger leaving behind traces that astronomers can still detect today. These remnants appear as streams of stars, faint arcs that stretch across the galaxy's outskirts, offering a visual narrative of Andromeda's growth over billions of years. Each of these mergers enriched Andromeda, adding new stars, gas, and dark matter to its structure. This ongoing process of galactic cannibalism is not unique to Andromeda. Our own Milky Way is undergoing similar transformations, as it slowly absorbs smaller galaxies like the Sagittarius dwarf spheroidal galaxy. Together, these two great spirals, Andromeda and the Milky Way, are part of a larger cosmic family known as the Local Group, a collection of more than 50 galaxies bound together by gravity. Dominated by Andromeda and the Milky Way, this group is a microcosm of the universe, showcasing the interplay of gravity, dark matter, and the evolution of galaxies over time. The fate of the Local Group is intrinsically tied to the future collision between Andromeda and the Milky Way. This event, often described as a galactic ballet, will unfold over billions of years, beginning with the galaxies drawing closer together under the influence of their mutual gravitational pull. Long before their stellar disks merge, the two galaxies' outer halos will interact, creating tidal streams and triggering bursts of star formation. As they collide, stars and gas will be flung into dramatic arcs, reshaping the galaxy's structures in a slow-motion dance that will eventually unite them as one. Despite the apparent violence of this process, the vast distances between individual stars mean that direct collisions between them will be rare. Instead, the merger will primarily involve the mixing of gas clouds, which will ignite waves of star formation as the interstellar material compresses under the immense gravitational forces. For billions of years, the new galaxy, a massive elliptical structure, will shine brightly with the light of young, hot stars born from this interaction. Over time, as star formation subsides, the merged galaxy will settle into a quieter state, its shape a testament to the transformative power of gravity. The idea of this merger offers profound insights into the dynamic nature of the universe. Far from being static and unchanging, galaxies are constantly evolving, shaped by interactions that occur over billions of years. This understanding challenges the way we perceive time and existence, reminding us that even the grandest structures in the cosmos are impermanent, subject to the inexorable forces of change. Andromeda also plays a crucial role in our understanding of dark matter, the mysterious substance that makes up about 85% of the universe's total mass. Observations of Andromeda's rotation reveal that its outer regions move much faster than they should based on the visible matter alone. This discrepancy is attributed to the presence of a vast halo of dark matter surrounding the galaxy, providing the gravitational pull necessary to explain its motion. By studying Andromeda's dark matter halo, scientists gain valuable insights into this elusive component of the universe, which remains one of the greatest enigmas in modern physics. Beyond the scientific revelations, Andromeda captures the imagination in a way that few other celestial objects can. Its proximity and visibility make it a favorite target for amateur astronomers, who marvel at the idea that they are gazing at another galaxy, one similar to the Milky Way but distinct in its details. For many, the experience of seeing Andromeda with the naked eye or through a telescope is transformative, a moment that bridges the gap between the vastness of the cosmos and the intimacy of human experience. The cultural significance of Andromeda is equally profound. Throughout history, it has inspired myths, art, and literature. The galaxy's name, rooted in Greek mythology, ties it to the story of Andromeda, the daughter of Cepheus and Cassiopeia, who was saved from a sea monster by the hero Perseus. This mythological connection imbues the galaxy with a sense of narrative and meaning, linking it to the stories that define human culture. In modern times, Andromeda has become a symbol of exploration and discovery, a reminder of humanity's desire to reach beyond the confines of our planet and connect with the cosmos. Carl Sagan once said that, "We are a way for the cosmos to know itself." Andromeda exemplifies this sentiment, serving as both an object of study and a source of inspiration. As we learn more about its structure, history, and future, we also learn more about ourselves and our place in the universe. The atoms that make up our bodies were forged in stars like those in Andromeda, linking us to the galaxy in a profound and tangible way. In this sense, the light of Andromeda is not just a beacon of scientific curiosity, it is a bridge that connects us to the broader narrative of existence. For future generations, Andromeda will remain a source of wonder and a challenge to our understanding of the cosmos. As technology advances, we may one day explore it directly, sending probes or even humans to study its stars and planets up close. Until then, its faint glow in the night sky will continue to inspire questions about who we are, where we come from, and where we are going. The Andromeda Galaxy, in all its complexity and beauty, is more than just a distant neighbor, it is a reminder of the infinite possibilities that await us as we journey ever deeper into the universe. The Andromeda Galaxy, our nearest large galactic neighbor, holds a nearly infinite capacity to awe and inspire, not just for what we know about it but also for the mysteries that remain unsolved. As we gaze at it from Earth, its faint light carries a profound message across the incomprehensible depths of time and space, reminding us of our shared origin in the stars and the uncharted future that lies ahead. To fully grasp Andromeda's significance, we must delve even deeper into its nature, its connection to our galaxy, and its role in shaping the cosmic landscape we call home. One of Andromeda's most striking features is its size. At roughly twice the width of the Milky Way, Andromeda spans over 220,000 light-years across and contains around 1 trillion stars, more than double the estimated 400 billion stars in our galaxy. Yet, the similarities between Andromeda and the Milky Way are equally striking. Both are spiral galaxies, with majestic, curving arms filled with stars, dust, and gas, forming a luminous dance around a dense, central core. This resemblance is no coincidence. Both galaxies formed in the same epoch of the early universe, shaped by the same forces of gravity, dark matter, and star formation. However, Andromeda is far from a static structure. Its immense size is a result of countless interactions with smaller galaxies over billions of years. These mergers have left visible scars, streams of stars and clusters that linger in its outskirts, remnants of galactic collisions long past. These traces are invaluable to astronomers, who use them as cosmic fossils to reconstruct Andromeda's evolutionary history. By studying the debris left behind by these interactions, scientists have pieced together a timeline of the galaxy's growth, revealing that Andromeda has consumed at least a dozen smaller galaxies in the last few billion years alone. This process of galactic cannibalism is not unique to Andromeda. It is a common mechanism in the evolution of large galaxies. Even our own Milky Way is in the midst of absorbing smaller galaxies, such as the Sagittarius dwarf galaxy, whose stars are being stretched into long, faint streams as they are pulled into our galaxy's gravitational embrace. These ongoing interactions, both in Andromeda and the Milky Way, highlight the dynamic nature of the universe, a constant process of creation, destruction, and renewal. The role of Andromeda in shaping the future of our cosmic neighborhood is even more profound. Its gravitational pull is already affecting the Milky Way, drawing our galaxy toward it at a speed of approximately 110 kilometers per second. This movement is part of a grander narrative, the inevitable collision of the two galaxies, set to occur in about 4 to 5 billion years. While the term collision might suggest chaos and destruction, the actual event will be more akin to a slow, graceful merging of two celestial giants. The stars within each galaxy are so far apart that direct collisions between them will be exceedingly rare. Instead, the gravitational forces will reshape both galaxies, flinging stars into new orbits and triggering waves of star formation as gas clouds collide and compress. Astronomers have used powerful computer simulations to model this future merger in exquisite detail. Initially, Andromeda and the Milky Way will approach each other, their immense halos of dark matter interacting before their stellar disks even touch. This interaction will create spectacular tidal tails, long streams of stars and gas pulled away from the galaxies by gravitational forces. Over the course of billions of years, the two galaxies will pass through one another multiple times, their shapes distorting with each encounter. Eventually, they will settle into a single, massive elliptical galaxy, often referred to as Milkomeda. This new structure will be a testament to the transformative power of gravity, a symbol of cosmic renewal on an incomprehensible timescale. For humanity, or whatever intelligent life might exist in the distant future, this merger will offer a dramatically different view of the night sky. Andromeda will grow larger and brighter with each passing eon, eventually dominating the heavens as it merges with the Milky Way. The spectacle will be both beautiful and profound, a reminder of the ever-changing nature of the universe. For future astronomers, the merged galaxy will be a singular laboratory, offering insights into the processes that shape galaxies and the long-term evolution of the cosmos. But the significance of Andromeda extends beyond its role in the local group or its eventual merger with the Milky Way. It also serves as a critical reference point for understanding fundamental questions about the universe. For example, observations of Andromeda's rotation have provided key evidence for the existence of dark matter. Without this mysterious substance, the galaxy's outer stars should not be moving as quickly as they do, given the amount of visible matter present. Instead, these stars orbit at speeds that can only be explained by the presence of an unseen mass, dark matter, that dominates the galaxy's gravitational field. By studying Andromeda, astronomers hope to unlock the secrets of dark matter, one of the most perplexing enigmas in modern physics. Andromeda also offers tantalizing possibilities for the search for life beyond Earth. With its trillion stars and countless planetary systems, the galaxy likely harbors an unimaginable diversity of worlds. Some of these planets may exist in the habitable zones of their stars, where conditions are suitable for liquid water and, potentially, life. While the vast distance between Earth and Andromeda makes direct exploration a challenge for now, future advancements in technology may one day allow us to study its exoplanets more closely, searching for signs of life or even civilizations. Culturally, Andromeda has become a symbol of exploration and the infinite possibilities of the universe. Its name, derived from Greek mythology, ties it to a story of courage, resilience, and discovery. In modern times, it has inspired countless works of art, literature, and science fiction, capturing the imagination of people around the world. For amateur astronomers, it is often the first galaxy they observe through a telescope, a gateway to the wonders of deep space. For scientists, Andromeda is more than an object of study, it is a reminder of the incredible progress humanity has made in understanding the universe. From the early work of Nicholas Copernicus, who first challenged the notion of an Earth-centered cosmos, to the groundbreaking discoveries of Edwin Hubble, who proved that Andromeda was a separate galaxy beyond the Milky Way, our journey of discovery has been shaped by the efforts of those who dared to look beyond the familiar. Carl Sagan, with his poetic vision of the cosmos, emphasized the importance of continuing this journey, urging us to embrace the unknown and celebrate our connection to the stars. The Andromeda Galaxy, with its immense scale and endless mysteries, embodies the spirit of exploration that defines humanity. It reminds us that while we are small in the grand scheme of the universe, we are capable of great things, of looking beyond ourselves and reaching for the stars. As we continue to study Andromeda, we not only learn more about the universe but also about ourselves, our origins, and our potential to shape the future. The light of Andromeda, traveling across millions of years, carries with it a message of hope, curiosity, and wonder, a beacon that calls us to keep exploring, to keep questioning, and to keep dreaming. The Andromeda Galaxy's light, traveling across 2.5 million years of space and time, invites us to contemplate not only the vastness of the cosmos but also the intricate web of connections that bind it together. Every photon that reaches our eyes is a silent messenger, carrying the story of distant stars, ancient collisions, and a future yet unwritten. To gaze upon Andromeda is to witness the grand narrative of the universe, unfolding across unimaginable distances and epochs. It is a reminder that, despite our seemingly fleeting existence, we are part of this story, a chapter in the cosmic epic that stretches back billions of years and will continue long after our time. Andromeda's beauty is not just in its vastness or its proximity but in the layers of history it contains. Its spiral arms, filled with glowing clouds of gas and clusters of young, hot stars, are a testament to ongoing star formation. These regions, known as H2 regions, are nurseries where new stars are born from the gravitational collapse of gas clouds. In contrast, the galaxy's core tells a different story, dominated by older, redder stars that have lived through the turbulence of Andromeda's mergers and collisions. This duality, of creation and antiquity, mirrors the life cycles of galaxies and stars across the universe. Perhaps most remarkable about Andromeda is the sense of time it conveys. The light we see today left the galaxy during a time when early humans were crafting tools and exploring their world. Andromeda's light brings us a snapshot of its past, frozen in the moment it began its journey to Earth. This ability to look back in time is one of the most profound aspects of astronomy, allowing us to witness the universe as it was millions or even billions of years ago. In this way, Andromeda serves as both a neighbor and a historian, preserving the events of its past for us to uncover. One of the greatest achievements of modern astronomy is our ability to unravel Andromeda's complex structure. With the aid of advanced telescopes and instruments, scientists have mapped its vast disk, its central bulge, and its extended halo. This halo, a nearly invisible sphere of hot, ionized gas and dark matter, is a subject of intense study. Stretching far beyond the visible galaxy, it interacts with the Milky Way's halo, forming a bridge between our two galaxies that will only grow stronger as they approach one another. Within this halo lies evidence of Andromeda's tumultuous history. Streams of stars, remnants of smaller galaxies it has consumed, weave intricate patterns through its outer regions. These stellar streams are like fingerprints, unique to the galaxies that once existed before being absorbed by Andromeda's gravitational pull. By studying these patterns, astronomers can reconstruct the timeline of Andromeda's growth, piecing together the story of its formation over billions of years. As Andromeda and the Milky Way draw closer, their gravitational dance will create phenomena that are both destructive and creative. Gas clouds from both galaxies will collide, compressing to form new stars in vast bursts of activity. Over time, the distinct shapes of both galaxies will dissolve, their spirals merging into a chaotic yet beautiful blend of stars, gas, and dark matter. The resulting galaxy will not resemble the spirals we know today but will instead take on an elliptical shape, a smooth, featureless structure typical of galaxies that have undergone major mergers. This cosmic event will not only reshape our local group of galaxies but also alter the dynamics of the broader universe. For billions of years, the new galaxy formed from the Milky Way and Andromeda will dominate the local group, its combined mass and gravity influencing the orbits of smaller satellite galaxies. Eventually, as these smaller galaxies are pulled into the growing structure, the local group itself will coalesce into a single, massive galaxy, completing a process that began when Andromeda and the Milky Way first started their journey toward one another. However, the Andromeda galaxy is more than just a future merger partner. It is a gateway to understanding the universe. Its proximity allows us to study phenomena that are common in distant galaxies but difficult to observe in detail. From the formation of massive star clusters to the dynamics of spiral arms, Andromeda provides a laboratory for understanding the processes that shape galaxies on both small and large scales. One of the most exciting areas of research involving Andromeda is the search for exoplanets within its vast array of stars. While current technology limits our ability to detect planets in other galaxies, Andromeda's size and star count suggest that it could host billions of planetary systems. Among these, there may be planets with conditions suitable for life, orbiting stars similar to our Sun. The possibility that life could exist in Andromeda, or that it once existed and left traces we have yet to detect, adds another layer of intrigue to this already fascinating galaxy. The philosophical implications of Andromeda are just as profound as the scientific ones. For centuries, humanity has looked to the heavens for answers about our place in the cosmos. Andromeda, with its vast scale and intricate structure, challenges us to think beyond the confines of our own solar system and even our own galaxy. It reminds us that the universe is not centered around us, as Nicholas Copernicus first demonstrated centuries ago, but is a vast, interconnected network of galaxies, stars, and planets, each playing its part in a grander whole. Carl Sagan often spoke of the importance of understanding the universe as a way of understanding ourselves. He described galaxies like Andromeda as islands in the cosmic ocean, places of beauty, mystery, and infinite potential. Through the study of Andromeda, we connect not only with the cosmos but also with our shared heritage as explorers and seekers of knowledge. We are part of a lineage that began with the earliest humans who looked up at the stars and continues today with scientists and dreamers pushing the boundaries of what we know. The Andromeda Galaxy is not merely a collection of stars, it is a symbol of the boundless possibilities that await us. As our technology advances, we may one day send probes or even humans to explore Andromeda directly, bridging the distance between our two galaxies and unlocking its secrets. Until that time, its faint glow in the night sky serves as a reminder of the incredible journey we are on, a journey that began with the first spark of curiosity and will continue as long as there are those willing to look beyond the horizon and dream of what lies beyond. In every sense, Andromeda is more than a neighbor, it is a reflection of our universe's past, a key to understanding its present, and a glimpse into its future. It invites us to imagine, to explore, and to embrace the infinite possibilities of the cosmos. Through Andromeda, we see not only a galaxy but also the potential of humanity itself, the power to question, to learn, and to reach for the stars. The Andromeda Galaxy, though vast and distant, is more than just an object of scientific inquiry or celestial admiration. It is a repository of knowledge, a symbol of human curiosity, and a testament to the enduring mysteries of the cosmos. Its sprawling arms, ancient core, and halo of dark matter form a bridge between what we know and what we seek to understand. As our nearest galactic neighbor, it challenges us to explore not just the physical universe, but also the philosophical and existential questions that arise when we look up at the night sky. To appreciate Andromeda fully, we must understand the staggering numbers that define it. Containing about 1 trillion stars, it outshines the Milky Way in both size and brightness. Its mass, including the enigmatic dark matter that surrounds it, is estimated to be nearly 1.5 times that of our galaxy. But numbers alone cannot capture its true majesty. Each star represents a potential solar system, a collection of planets and moons that could harbor unimaginable diversity and complexity. Among them, there may be worlds that resemble our own, complete with oceans, mountains, and perhaps even life. Life in Andromeda, if it exists, would be an extraordinary discovery, not just because it would expand our understanding of biology but because it would reveal that the processes leading to life are universal. The stars of Andromeda are chemically similar to those in the Milky Way, having been forged in the same cosmic crucibles of hydrogen and helium that birthed our Sun. This chemical commonality suggests that the building blocks of life, carbon, oxygen, nitrogen, and other essential elements, are present throughout the universe, including in Andromeda. Yet Andromeda's value extends far beyond its potential for harboring life. It is a treasure trove for understanding the evolution of galaxies. The streams of stars in its outer regions, remnants of smaller galaxies it has consumed, offer insights into how large galaxies grow through mergers and interactions. These tidal streams, faint but detectable with modern telescopes, serve as a cosmic archaeological record, allowing scientists to piece together the events that shaped Andromeda over billions of years. Andromeda's interaction with the Milky Way is part of a larger narrative of cosmic evolution. As members of the local group, these two galaxies are bound together by gravity, along with dozens of smaller satellite galaxies such as the Magellanic Clouds and the Triangulum Galaxy. The local group itself is part of an even larger structure, the Virgo supercluster, which is one of countless superclusters spread across the observable universe. This hierarchy of structures, from individual stars to galaxies to superclusters, demonstrates the interconnectedness of the cosmos and the forces that shape it. The impending collision between Andromeda and the Milky Way is perhaps one of the most dramatic chapters in this narrative. While the event is billions of years away, its inevitability underscores the dynamic nature of the universe. Galaxies are not static entities, they are constantly moving, changing, and interacting. The collision will unfold over billions of years, reshaping the night sky and altering the structure of both galaxies. In the early stages of the merger, Andromeda will appear as a bright, elongated object in the night sky, growing larger and more detailed as it approaches. Stars and gas from both galaxies will be drawn into vast tidal streams, creating a chaotic yet beautiful display of cosmic forces. As the galaxies merge, their supermassive black holes will spiral toward one another, eventually combining to form an even larger black hole at the center of the newly formed galaxy. This process will release enormous amounts of energy, creating jets of radiation that could be visible across great distances. The collision will also trigger a burst of star formation as clouds of gas and dust collide and compress. This starburst phase will produce millions of new stars, some of which may go on to form planetary systems. For any future observers in the merged galaxy, the sky will be filled with the light of these young stars, a stark contrast to the relatively stable skies we see today. While the collision between Andromeda and the Milky Way will be a transformative event, it is not unique. Astronomers have observed similar mergers in distant galaxies, providing a preview of what might occur in our own cosmic backyard. These observations reveal that such interactions are a natural part of galactic evolution, driven by the relentless pull of gravity. They also remind us that the universe is a dynamic and ever-changing place, where even seemingly stable structures are subject to the forces of time and physics. Andromeda's role as a beacon of curiosity and wonder cannot be overstated. For millennia, it has been a fixture in the night sky, inspiring myths, stories, and scientific inquiry. The ancient Greeks named it after the mythical princess Andromeda, linking the galaxy to a tale of heroism and salvation. In the modern era, it has become a symbol of the vastness of the universe and humanity's desire to explore it. Carl Sagan, in his iconic series Cosmos, described galaxies like Andromeda as islands in the cosmic ocean. This metaphor captures both the isolation and the interconnectedness of galaxies. Each galaxy is a self-contained world, yet all are part of the same universe, governed by the same physical laws. For Sagan, Andromeda was not just a distant object, it was a reminder of the unity of the cosmos and our place within it. The scientific study of Andromeda has also played a pivotal role in our understanding of the universe. Edwin Hubble's discovery that Andromeda was a galaxy beyond the Milky Way transformed our perception of the cosmos, revealing that the universe is far larger than previously imagined. This discovery laid the foundation for modern cosmology, leading to the realization that the universe is expanding and that galaxies are moving away from one another. Andromeda continues to be a focus of cutting-edge research. With advances in technology, astronomers can now study its individual stars, star clusters, and planetary nebulae in unprecedented detail. Instruments like the Hubble Space Telescope and the upcoming James Webb Space Telescope allow scientists to probe the galaxy's structure, composition, and history. These observations not only deepen our understanding of Andromeda but also provide a window into the processes that shape all galaxies. In many ways, Andromeda is a mirror. It reflects the complexity of the universe and the processes that have shaped our own galaxy. It also reflects our own journey as a species, from ancient stargazers who marveled at its faint glow to modern scientists who unravel its secrets. Andromeda challenges us to think big, to question our assumptions, and to embrace the unknown. The light of Andromeda, traveling across millions of years, carries more than just information about a distant galaxy. It carries a message of connection, resilience, and discovery. It reminds us that we are part of something far greater than ourselves, a universe of infinite possibility, bound together by the same forces that shape the stars, the planets, and life itself. Through Andromeda, we glimpse not only the cosmos but also the enduring spirit of humanity, forever reaching, forever exploring, forever dreaming. The Andromeda Galaxy is more than just a neighbor in space, it is a gateway to understanding the vast and intricate workings of the universe. Its light, which began its journey millions of years before human civilization emerged, connects us to a time and place far removed from our own. Yet, this connection is not abstract, it is deeply tangible. The photons from Andromeda that strike our telescopes and eyes today were born in its stars, the same kinds of stars that fill our Milky Way and gave rise to the elements that make up our own world. In Andromeda, we find a reflection of ourselves, not in a literal sense, but in the shared processes that have shaped galaxies, stars, and life across the cosmos. The story of Andromeda is a story of growth and change, of creation and destruction on a scale that defies comprehension. This spiral galaxy, with its luminous arms and dense core, has grown over billions of years through a series of mergers and collisions with smaller galaxies. These interactions are not random, they are the inevitable result of the universe's structure, where gravity pulls galaxies together in a slow but unyielding dance. Andromeda's growth through these mergers has left behind evidence that astronomers can study today, streams of stars and clusters that stretch across its halo, tracing the remnants of smaller galaxies long since absorbed into its structure. These stellar streams are not just remnants of the past, they are also keys to understanding Andromeda's future. By analyzing their motion and composition, scientists can reconstruct the galaxy's history and predict how it will evolve. For instance, Andromeda's massive halo of dark matter, an invisible but essential component of its structure, provides the gravitational pull that has allowed it to grow so large. This halo also interacts with the Milky Way's dark matter halo, creating a gravitational bridge that binds our two galaxies together. This connection will only grow stronger as Andromeda and the Milky Way continue their inexorable approach. The collision between Andromeda and the Milky Way, predicted to occur in about 4 to 5 billion years, is one of the most anticipated events in the cosmos. This galactic merger will not be a sudden or violent collision but a slow, dramatic transformation that unfolds over billions of years. As the two galaxies approach each other, their shapes will distort, and their stars will be flung into long, arcing streams. These tidal interactions will create a breathtaking display of light and motion, visible to any future observers who may still inhabit Earth or nearby worlds. The collision will also trigger a burst of star formation as gas clouds from both galaxies collide and compress. This starburst phase will create millions of new stars, some of which may form planetary systems capable of supporting life. For any intelligent beings living in this merged galaxy, the night sky will be unrecognizable, filled with the light of young, hot stars and the remnants of the two original galaxies. Over time, the distinct spiral shapes of Andromeda and the Milky Way will fade, replaced by a massive elliptical galaxy. This new structure, sometimes referred to as Milkomeda, will dominate the local group, a collection of more than 50 galaxies that includes Andromeda, the Milky Way, and the smaller Triangulum galaxy. The local group itself is part of an even larger structure, the Virgo supercluster, which contains thousands of galaxies spread across hundreds of millions of light-years. These cosmic hierarchies remind us that even events as monumental as the merger of two galaxies are part of a much grander narrative. But Andromeda's importance is not limited to its role in the future of the Milky Way. It is also a cornerstone of modern astronomy, providing critical insights into the nature of galaxies and the universe as a whole. Edwin Hubble's discovery that Andromeda is a separate galaxy beyond the Milky Way was a transformative moment in our understanding of the cosmos. This revelation not only expanded the known universe but also established that galaxies are the fundamental building blocks of the cosmos, each containing billions or trillions of stars. Andromeda has also been instrumental in the study of dark matter, the mysterious substance that makes up about 85% of the universe's mass. By observing the rotation of Andromeda's disk, astronomers discovered that its outer stars moved much faster than they should based on the visible matter alone. This discrepancy can only be explained by the presence of a vast halo of dark matter surrounding the galaxy. Understanding dark matter is one of the greatest challenges in modern physics, and Andromeda serves as a vital laboratory for unraveling this mystery. In addition to its scientific significance, Andromeda holds a special place in human culture. Its name, rooted in Greek mythology, links it to the story of a princess who was saved from a sea monster by the hero Perseus. This mythological connection imbues the galaxy with a sense of narrative and meaning, reminding us that the cosmos has always been a source of inspiration and wonder. In modern times, Andromeda has become a symbol of exploration, representing humanity's desire to reach beyond the confines of Earth and understand the universe. For amateur astronomers, Andromeda is often the first galaxy they observe, a faint, oval-shaped glow that becomes a gateway to the wonders of deep space. Through telescopes, it reveals its spiral arms, its dense core, and even its companion galaxies, M32 and M110. These smaller galaxies, which orbit Andromeda, are themselves fascinating objects of study, providing further clues about the processes that shape galaxies. Andromeda also invites us to consider the possibility of life beyond Earth. With its trillion stars and countless planetary systems, the galaxy likely harbors an unimaginable diversity of worlds. Among them, there may be planets with conditions suitable for life, orbiting stars much like our Sun. While the vast distance between Earth and Andromeda makes direct exploration a distant dream, future advancements in technology may allow us to detect signs of life on planets within its stars. Such a discovery would not only transform our understanding of life in the universe but also deepen our connection to Andromeda as a fellow inhabitant of the cosmos. Philosophically, Andromeda challenges us to think about our place in the universe. It is a reminder that we are not the center of the cosmos but part of a vast, interconnected web of galaxies, stars, and planets. This perspective, first introduced by Nicholas Copernicus and later expanded by scientists like Edwin Hubble and Carl Sagan, has reshaped how we see ourselves and our relationship to the universe. Sagan, in particular, saw galaxies like Andromeda as symbols of both the immensity of the cosmos and the potential of humanity. He often spoke of the cosmic ocean, in which galaxies are islands of stars separated by vast expanses of space. For Sagan, Andromeda was a beacon of curiosity and wonder, a reminder that we are part of something far greater than ourselves. As we continue to study Andromeda, we are not only learning about the universe but also about ourselves. The light from its stars connects us to a shared cosmic heritage, linking the atoms in our bodies to the elements forged in distant supernovae. It reminds us that we are, in Sagan's words, star stuff, born from the same processes that shaped Andromeda and the Milky Way. In every sense, Andromeda is more than a galaxy, it is a symbol of the infinite possibilities that lie beyond our world. Its light carries a message of resilience, curiosity, and discovery, inviting us to explore, to question, and to dream. Through Andromeda, we glimpse not only the universe but also the enduring spirit of humanity, forever reaching for the stars. The Andromeda Galaxy beckons us to imagine, to reflect, and to reach further than ever before. Its light, traveling across millions of years, has crossed an immense cosmic chasm to deliver a message from the past. That message is one of continuity, transformation, and infinite potential. To study Andromeda is to peer into the dynamics of an evolving universe, to witness processes that mirror those in our own galaxy, and to uncover clues that reveal how galaxies, and perhaps life itself, form, grow, and change over time. At its core, Andromeda is a study in contrasts, creation and destruction, stability and flux. Its spiral arms are regions of intense star formation, where cold clouds of gas and dust collapse under the influence of gravity to ignite new stars. These regions glow brightly in ultraviolet light, revealing the presence of young, hot stars that will live fast and die spectacularly, enriching their surroundings with heavier elements through supernova explosions. In contrast, the central bulge of Andromeda is a graveyard of ancient stars, cooler and dimmer, yet no less vital to the galaxy's structure. These stars, enriched by the remnants of countless stellar generations, provide the mass and gravitational pull that stabilize Andromeda's luminous spiral arms. But the galaxy's visible stars, as breathtaking as they are, make up only a fraction of its total mass. Surrounding Andromeda is an enormous halo of dark matter, a mysterious and invisible substance that exerts a gravitational influence far beyond the reach of the galaxy's visible disk. This dark matter halo not only holds Andromeda together but also governs its interactions with neighboring galaxies, including our own Milky Way. Without dark matter, the outer stars of Andromeda would fly off into space, unable to be held in their orbits by the visible mass alone. This unseen component underscores one of the greatest mysteries in modern astrophysics, challenging us to understand the true nature of the universe's most abundant form of matter. Andromeda's halo also plays a crucial role in its gravitational relationship with the Milky Way. The two galaxies are like celestial dancers, drawn together by an unseen connection. Even now, Andromeda is approaching us at a speed of about 110 kilometers per second, a pace that will bring the two galaxies into a cosmic embrace in roughly 4 to 5 billion years. The thought of two massive galaxies merging may seem cataclysmic, yet it is part of the natural order of the universe. Galactic collisions and mergers are not the exception, they are the rule. They are how galaxies grow, evolve, and enrich themselves over cosmic timescales. This future collision will be a defining moment in the life of both Andromeda and the Milky Way. As the galaxies draw closer, their shapes will distort under the influence of tidal forces, stretching their stars into long, elegant streams that will crisscross the heavens. The halos of dark matter that surround each galaxy will interact first, blending into a unified gravitational field. Then, as their stellar disks collide, gas and dust clouds will compress, triggering an explosion of star formation. This burst of activity will illuminate the universe with countless young stars, burning brightly in a night sky that will look nothing like the one we know today. Over billions of years, the galaxies will merge completely, forming a single, massive elliptical galaxy. This new structure will no longer have the intricate spiral arms of Andromeda or the Milky Way but will instead take on a smoother, more featureless shape, a hallmark of galaxies that have undergone major mergers. For any future observers who may inhabit this new galaxy, the skies will tell a story of unity, a blending of two distinct cosmic entities into a single, larger whole. This merger is not an isolated event. It is part of a grander cosmic dance that has been playing out since the universe's inception. In the vast expanse of the universe, galaxies are not solitary islands, they exist in clusters, groups, and superclusters, bound together by gravity. Andromeda and the Milky Way are part of the local group, a collection of more than 50 galaxies that includes the Triangulum Galaxy and a host of smaller dwarf galaxies. Over time, the local group will itself merge into a larger structure, likely becoming part of the Virgo supercluster, a process that will take trillions of years to unfold. As Andromeda draws closer, it also invites deeper questions about the universe and our place within it. What will happen to the stars, planets, and potentially habitable worlds within both galaxies during the merger? While direct collisions between stars are exceedingly rare due to the vast distances between them, the gravitational disturbances caused by the merger will likely eject some stars into intergalactic space. Others may be pulled into new orbits, and some may even end up in the cores of the merging galaxies, feeding the central supermassive black hole. The merger may also give rise to entirely new planetary systems, formed from the gas and dust compressed during the collision. These new worlds, born from the union of Andromeda and the Milky Way, could one day become the cradles of life, continuing the legacy of exploration and discovery that began in their parent galaxies. For scientists, Andromeda offers a unique opportunity to study these processes in detail. Because it is the closest large galaxy to the Milky Way, it serves as a model for understanding galactic structure and evolution on both small and large scales. With advanced telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope, astronomers are able to observe Andromeda's stars, gas clouds, and dark matter halo with unprecedented precision. These observations not only deepen our understanding of Andromeda but also provide critical insights into the dynamics of galaxies across the universe. Andromeda's significance extends beyond the realm of science. It is a cultural icon, a source of inspiration for countless generations. Its name, derived from Greek mythology, connects it to a story of bravery and salvation, a narrative that has been passed down through the ages. In modern times, Andromeda has become a symbol of exploration and the limitless possibilities of the cosmos. For amateur astronomers, it is often the first galaxy they observe, a faint, glowing oval in the night sky that hints at the vastness beyond our solar system. For philosophers and dreamers, Andromeda represents the ultimate frontier, a distant, unreachable realm that reminds us of both our insignificance and our potential. It challenges us to think beyond the confines of our planet and our moment in time, to imagine a universe filled with worlds and civilizations waiting to be discovered. Carl Sagan captured this sense of wonder when he described galaxies like Andromeda as islands in the cosmic ocean. To Sagan, Andromeda was not just a distant object to be studied, it was a reminder of the interconnectedness of all things. The atoms in our bodies, forged in the hearts of ancient stars, are the same as those in Andromeda's stars. This shared heritage connects us to the galaxy in a profound and tangible way, linking our existence to the grand processes that shape the universe. As humanity continues its journey of discovery, Andromeda will remain a beacon of curiosity and wonder. It is a reminder of how far we have come, from ancient stargazers who saw it as a faint smudge in the sky to modern scientists who unravel its secrets with powerful telescopes. It is also a reminder of how far we have yet to go, as we strive to understand the universe and our place within it. Through Andromeda, we glimpse not only the cosmos but also the enduring spirit of humanity, our capacity for curiosity, exploration, and imagination. Its light, crossing millions of years and vast distances, carries with it a message of connection, resilience, and infinite possibility. In its glow, we find not just a galaxy but a reflection of our own journey, a journey that began with the first spark of wonder and will continue as long as there are those who dare to look beyond the horizon and dream of what lies beyond. The Andromeda Galaxy, with its trillion stars and sprawling spiral arms, is more than a neighbor in space, it is a profound symbol of the cosmos' complexity, a bridge to our past, and a window into our future. Its story spans billions of years, encompassing creation, destruction, and transformation on an epic scale. Yet its light, faintly visible from Earth, serves as a constant reminder of the interconnectedness of all things and humanity's enduring desire to understand our place in the universe. This galaxy, located 2.5 million light-years from Earth, is the largest and most massive member of our local group of galaxies. Its gravitational influence extends far beyond its visible disk, encompassing a halo of dark matter that interacts with similar halos around other galaxies in the group, including our own Milky Way. Together, these gravitational interactions define the structure and destiny of our cosmic neighborhood. Andromeda's structure is a masterpiece of galactic evolution. Its central bulge is a dense region of older, redder stars that orbit a supermassive black hole estimated to be about 100 million times the mass of our Sun. This black hole, hidden within Andromeda's core, exerts a gravitational force so immense that it controls the motion of stars thousands of light-years away. Surrounding this bulge are Andromeda's signature spiral arms, sprawling regions rich with gas, dust, and young, luminous stars. These arms are not static, they are shaped by the galaxy's rotation and by gravitational interactions with nearby companion galaxies, M32 and M110, which orbit Andromeda like moons around a planet. Andromeda's arms are also home to vast stellar nurseries, regions where cold gas collapses under gravity to form new stars. These star-forming regions, illuminated by ultraviolet light, are evidence that the galaxy is still growing and evolving. Yet, Andromeda's star formation is not uniform. It reflects the galaxy's turbulent history, marked by mergers and interactions with smaller galaxies. Each of these events has left behind evidence, streams of stars and globular clusters that trace the remnants of galaxies long since absorbed into Andromeda's mass. These stellar streams, visible with modern telescopes, are like cosmic fossils. They provide clues about Andromeda's past, revealing how it grew from a smaller, simpler structure into the massive galaxy we see today. By studying these streams, astronomers can reconstruct the timeline of Andromeda's mergers, shedding light on the processes that shape galaxies throughout the universe. These findings have profound implications for understanding our own Milky Way, which is undergoing similar processes, albeit on a smaller scale. Andromeda's significance extends beyond its role as a nearby galaxy. It has played a pivotal role in the history of astronomy, helping scientists redefine our understanding of the universe. Before the early 20th century, astronomers believed that the Milky Way encompassed the entire universe and that objects like Andromeda were simply nebulae within it. This changed with Edwin Hubble's groundbreaking discovery in the 1920s. Using the 100-inch telescope at Mount Wilson Observatory, Hubble identified Cepheid variable stars in Andromeda, stars whose brightness varies in a predictable way, allowing their distances to be measured accurately. His observations proved that Andromeda was far outside the Milky Way, a separate galaxy entirely. This revelation was transformative. It expanded the known universe by orders of magnitude and established that galaxies are the fundamental building blocks of the cosmos. Hubble's work also laid the foundation for modern cosmology, leading to the discovery that the universe is expanding. Andromeda, once thought to be a faint, nearby cloud of gas, became a cornerstone of our understanding of the universe's vastness and dynamic nature. Today, Andromeda continues to be a focus of scientific inquiry. Its proximity makes it an ideal laboratory for studying the processes that shape galaxies, from star formation to the mysterious influence of dark matter. Observations of Andromeda's rotation curve, the way its stars orbit at different speeds, have provided critical evidence for the existence of dark matter. Without this invisible substance, the outer stars of Andromeda would not move as quickly as they do, they would lack the gravitational pull needed to keep them in orbit. This discovery has profound implications for our understanding of the universe, as dark matter makes up roughly 85% of all matter, yet its true nature remains elusive. The Andromeda galaxy also serves as a guide to our future. Its approach toward the Milky Way is a harbinger of a monumental event, the eventual collision and merger of our two galaxies. This galactic dance, set to begin in about 4 to 5 billion years, will reshape both galaxies in ways that are both dramatic and beautiful. The process will not be a sudden impact but a gradual, intricate interaction spanning billions of years. As the galaxies approach each other, their gravitational forces will distort their shapes, pulling stars into long tidal streams that will crisscross the night sky. When the galaxies finally merge, their central black holes will spiral toward one another, eventually coalescing into a single, even larger black hole. The merger will also trigger bursts of star formation, as gas clouds collide and compress. These new stars will illuminate the galaxy, creating a breathtaking spectacle that future observers, if any exist, will witness firsthand. The resulting galaxy, often referred to as Milkomeda, will be a massive elliptical galaxy, lacking the spiral arms that characterize both Andromeda and the Milky Way today. Its structure will reflect the history of its formation, a testament to the forces of gravity and time that govern the universe. For the local group, this merger will mark a new era, as smaller galaxies are gradually absorbed into the larger structure. But the significance of Andromeda is not confined to its scientific or astronomical importance. It is also a cultural and philosophical symbol, a reminder of humanity's place in the cosmos. Its light, faint but visible to the naked eye, has inspired myths, stories, and scientific inquiry for centuries. Ancient cultures, lacking the tools to study it scientifically, wove Andromeda into their legends, linking it to tales of heroism and the gods. In Greek mythology, the galaxy is named after Andromeda, the daughter of Cepheus and Cassiopeia, who was saved from a sea monster by the hero Perseus. This connection between the galaxy and human storytelling highlights the enduring bond between the cosmos and our imagination. In the modern era, Andromeda represents the spirit of exploration and discovery. For amateur astronomers, it is often the first galaxy observed, a gateway to the wonders of deep space. For scientists, it is a wellspring of data and a testing ground for theories about the universe. And for philosophers and dreamers, it is a reminder of both our smallness and our potential, a symbol of the infinite possibilities that lie beyond our world. Carl Sagan, in his poetic reflections on the cosmos, often spoke of the interconnectedness of all things. He described galaxies like Andromeda as islands in the cosmic ocean, places of mystery and wonder that remind us of the unity of the universe. For Sagan, Andromeda was not just a distant galaxy, it was a mirror, reflecting our own existence and the forces that shaped us. Through Andromeda, we glimpse the universe as it truly is, vast, dynamic, and ever-changing. Its light, crossing millions of years and billions of kilometers, connects us to a time and place far removed from our own yet intimately linked to it. It is a reminder that we are part of something much larger than ourselves, a cosmos filled with galaxies, stars, and possibilities yet to be discovered. As we continue to study Andromeda, we deepen not only our understanding of the universe but also our connection to it. We are star stuff, as Carl Sagan famously said, forged in the same cosmic crucibles that created Andromeda and the Milky Way. This shared origin binds us to the galaxy in ways that are both profound and tangible, linking our existence to the grand narrative of the cosmos. Andromeda's story is our story, a story of creation, evolution, and discovery that spans billions of years. Its light, reaching us across the void of space, carries a message of hope, curiosity, and wonder. It reminds us that while we may be small in the grand scheme of the universe, we are capable of great things, of looking beyond ourselves, of seeking answers, and of dreaming of what lies beyond. Through Andromeda, we find not just a galaxy but a reflection of our own journey, a testament to the enduring spirit of humanity and our unyielding desire to explore the infinite. The Andromeda Galaxy's story is a cosmic epic that intertwines with the history of our universe and our place within it. Its light, visible across the dark canvas of the night sky, carries with it an unspoken promise of discovery, a reminder of how much more there is to learn and understand. Stretching over 220,000 light-years in diameter and containing approximately 1 trillion stars, Andromeda is a beacon of astronomical wonder and scientific curiosity. But beyond its immense physical presence, it invites us to reflect on the mysteries of the cosmos, the resilience of galaxies, and the fundamental forces that bind the universe together. This galaxy is not just a static object but a dynamic, ever-evolving system, alive with activity. Its spiral arms swirl outward from a bright, dense core, where a supermassive black hole lies at its heart. This black hole, millions of times the mass of our Sun, acts as a gravitational anchor, influencing the orbits of stars and gas clouds throughout Andromeda. Surrounding the core are vast fields of older stars, remnants of earlier epochs in the galaxy's history. These stars are a living record of Andromeda's past, shining faintly as they age, their light carrying the echoes of billions of years of cosmic evolution. But the true story of Andromeda lies in its outer regions, where the remnants of countless galactic collisions are etched into its structure. Streams of stars, tidal tails created by gravitational interactions, stretch across Andromeda's halo, the faint but undeniable evidence of its past mergers with smaller galaxies. Each of these streams tells a tale of cosmic growth, of smaller galaxies pulled into Andromeda's gravitational grip, their stars redistributed into new orbits as they became part of this giant spiral. These interactions are not random, they are part of a broader narrative of galactic evolution, where gravity acts as the sculptor of the cosmos. Even today, Andromeda continues to grow. It is actively pulling in and assimilating smaller galaxies in its vicinity, including its companion galaxies, M32 and M110. These dwarf galaxies orbit Andromeda like satellites, their orbits shaped by its immense gravitational pull. Over time, these companions will likely be absorbed into Andromeda, their stars and gas contributing to its mass. This process of galactic cannibalism is not unique to Andromeda, it is a common phenomenon throughout the universe. In fact, our own Milky Way is currently absorbing smaller galaxies, such as the Sagittarius dwarf galaxy, whose stars are being stretched into long streams visible in our galaxy's outer regions. These processes of growth and interaction are driven by the invisible scaffolding of dark matter. Surrounding Andromeda is a massive halo of dark matter, extending far beyond its visible disk. This dark matter halo, while unseen, exerts a gravitational influence that shapes the motion of stars and galaxies within Andromeda's sphere of influence. Without dark matter, Andromeda's outer stars would not remain in their orbits, they would simply drift away into space. The presence of dark matter is one of the great revelations of modern astronomy, and Andromeda provides a natural laboratory for studying this mysterious substance, which comprises roughly 85% of the universe's total mass. The future of Andromeda is intertwined with that of the Milky Way. The two galaxies, the largest in the local group, are on a collision course that will culminate in a dramatic merger roughly 4 to 5 billion years from now. This impending collision, while seemingly cataclysmic, is part of the natural life cycle of galaxies. Observations of distant galaxies show that mergers and collisions are common, fundamental to the growth and evolution of large galaxies like Andromeda and the Milky Way. As Andromeda and the Milky Way draw closer, their gravitational forces will begin to interact more strongly, distorting their shapes and pulling stars and gas into long tidal streams. For billions of years, the galaxies will engage in a slow-motion dance, passing through each other several times before finally merging. During this process, the stars of both galaxies will mostly avoid direct collisions, as the distances between stars are vast compared to their sizes. However, the gas clouds within the galaxies will collide and compress, triggering bursts of star formation that will light up the night sky. The eventual merger will produce a single, massive elliptical galaxy, sometimes referred to as Milkomeda. This new galaxy will lack the intricate spiral arms of its predecessors, its structure smoothed out by the gravitational forces of the merger. Its central black hole, formed from the merging of the supermassive black holes in Andromeda and the Milky Way, will dominate its core, surrounded by the combined stellar populations of the two original galaxies. For any future observers in this new galaxy, the skies will look entirely different, filled with the remnants of the merger and the light of newly formed stars. The merger of Andromeda and the Milky Way is not just a local event, it is part of a broader cosmic narrative. Our local group of galaxies is itself part of the Virgo supercluster, a vast collection of galaxies spanning hundreds of millions of light-years. Over time, gravity will draw the galaxies within the Virgo supercluster closer together, eventually forming a single, massive structure. This process, while taking trillions of years, highlights the dynamic nature of the universe, where even the largest structures are in a constant state of flux. But Andromeda's importance extends beyond its role in shaping the future of the local group. It also offers profound insights into the nature of galaxies and the forces that govern the universe. By studying Andromeda, astronomers have uncovered fundamental truths about star formation, galactic dynamics, and the role of dark matter. Its proximity allows scientists to observe details that are impossible to see in more distant galaxies, making it an invaluable tool for testing theories about how galaxies form and evolve. Culturally, Andromeda has inspired humanity for centuries. Its faint glow has been observed by countless generations, from ancient skywatchers to modern astronomers. For the ancient Greeks, Andromeda was woven into their mythology, named after a princess who was saved by the hero Perseus. This connection between the galaxy and human storytelling underscores its timeless role as a source of wonder and inspiration. In modern times, Andromeda symbolizes humanity's desire to explore and understand the universe. It has been the subject of countless scientific studies, artistic works, and philosophical reflections. For amateur astronomers, it is often the first galaxy observed, a gateway to the vastness of the cosmos. For scientists, it is a treasure trove of data, offering clues about the fundamental processes that shape galaxies. Andromeda also challenges us to think about the possibility of life beyond Earth. With its trillion stars and countless planetary systems, the galaxy likely harbors an unimaginable diversity of worlds. Some of these planets may exist in the habitable zones of their stars, where conditions are right for liquid water and, potentially, life. While the vast distance between Earth and Andromeda makes direct exploration unlikely for now, future technologies may one day allow us to detect signs of life on its planets. Philosophically, Andromeda reminds us of the unity of the cosmos. As Carl Sagan often said, we are star stuff, connected to the universe through the same processes that created galaxies, stars, and planets. The atoms in our bodies were forged in the hearts of stars like those in Andromeda, linking us to the galaxy in a profound and tangible way. This connection is a reminder that we are part of something much larger than ourselves, a cosmos filled with beauty, mystery, and infinite possibilities. Through Andromeda, we glimpse the grandeur of the universe and the resilience of galaxies that have endured for billions of years. Its light, crossing millions of years to reach us, carries a message of continuity, exploration, and discovery. It invites us to dream, to question, and to reach beyond the limits of what we know. As we continue to study Andromeda, we uncover not only the secrets of the galaxy but also the enduring spirit of humanity, a spirit defined by curiosity, imagination, and an unyielding desire to explore the infinite. The Andromeda Galaxy stands as one of the most fascinating celestial objects in the universe, not just for its scientific significance but also for its cultural and philosophical implications. Its light, traveling across 2.5 million years of space and time, bridges an extraordinary gap in both distance and understanding. This light is a messenger from a realm far removed from our immediate reality, yet it connects us to processes that have shaped not only our galaxy but also the universe as a whole. To study Andromeda is to step into a cosmic narrative that spans billions of years, a story of growth, interaction, and transformation on a scale that challenges the boundaries of human imagination. At first glance, Andromeda's faint glow in the night sky belies its true nature. It is a sprawling spiral galaxy, home to 1 trillion stars and countless planetary systems. Its size alone dwarfs our Milky Way, making it the dominant member of the local group, a collection of more than 50 galaxies bound together by gravity. These galaxies, which include the Triangulum Galaxy and a host of smaller dwarf galaxies, are not isolated entities. They interact with one another, exchanging stars and gas over billions of years, their movements governed by the invisible framework of dark matter that permeates the universe. Dark matter is one of Andromeda's most intriguing mysteries. Though it cannot be seen, its effects are unmistakable. Observations of Andromeda's rotation reveal that its outer stars move far faster than they should, given the amount of visible matter in the galaxy. This discrepancy can only be explained by the presence of a vast halo of dark matter, enveloping Andromeda and extending far beyond its visible disk. This halo not only holds the galaxy together but also influences its interactions with neighboring galaxies, including the Milky Way. Understanding dark matter is one of the great challenges of modern astrophysics, and Andromeda offers a unique window into its nature. Andromeda's history is equally compelling. Like all galaxies, it began as a collection of gas and dark matter in the early universe. Over billions of years, gravity pulled this material together, forming the first stars and clusters that would later coalesce into a protogalaxy. But Andromeda's growth did not stop there. It continued to evolve through a series of mergers and collisions with smaller galaxies, events that enriched its structure and added to its mass. These interactions are not merely theoretical, they are visible in the form of tidal streams, long arcs of stars that stretch across Andromeda's halo, remnants of galaxies that were torn apart and absorbed into its gravitational embrace. These tidal streams are more than just remnants of past interactions, they are clues to Andromeda's future. By studying their motion and composition, astronomers can reconstruct the galaxy's evolutionary history and predict its ultimate destiny. Andromeda is not static, it is in constant motion, influenced by the gravitational pull of its neighbors. Chief among these is the Milky Way, which is drawing closer to Andromeda at a speed of 110 km per second. This movement will culminate in a cosmic event of unparalleled significance, the collision and merger of our two galaxies. The impending collision, set to occur in about 4 to 5 billion years, is a reminder of the dynamic nature of the universe. While galaxies may appear stable on human timescales, they are anything but static. They grow, change, and interact over billions of years, shaped by the relentless pull of gravity. The merger of Andromeda and the Milky Way will be a slow-motion dance, unfolding over billions of years. As the galaxies approach each other, their gravitational forces will distort their shapes, creating long tidal tails of stars and gas that will light up the night sky. The collision will also trigger bursts of star formation as gas clouds from both galaxies collide and compress. These starbursts will produce millions of new stars, some of which may host planets capable of supporting life. For any future inhabitants of these galaxies, the night sky will be transformed, filled with the light of young, hot stars and the remnants of the two merging galaxies. Over time, the distinct spiral structures of Andromeda and the Milky Way will fade, replaced by a massive elliptical galaxy. This new galaxy, sometimes referred to as Milkomeda, will dominate the local group, its formation marking the end of an era and the beginning of a new chapter in the history of the cosmos. The merger of Andromeda and the Milky Way is not an isolated event. It is part of a broader cosmic cycle, one that has been unfolding since the birth of the universe. Galaxies are not solitary entities, they exist within clusters and superclusters, bound together by gravity. Over time, these structures interact and merge, creating ever larger formations. The local group itself is part of the Virgo supercluster, a vast collection of galaxies that spans hundreds of millions of light-years. And beyond the Virgo supercluster lies the Laniakea supercluster, an even larger structure that encompasses thousands of galaxies, including our own. These cosmic hierarchies remind us of the scale of the universe and our place within it. They also challenge us to think beyond the immediate and the familiar, to consider the forces that shape the cosmos on the largest scales. Andromeda, as a nearby galaxy, provides a crucial link in this chain of understanding. Its proximity allows astronomers to study phenomena that are difficult or impossible to observe in more distant galaxies, from the dynamics of spiral arms to the effects of dark matter on galactic rotation. But Andromeda's significance is not limited to its scientific value. It also holds a special place in human culture and imagination. For centuries, it has been a source of wonder and inspiration, appearing in myths, stories, and scientific explorations. Its name, derived from Greek mythology, ties it to a story of heroism and salvation, a narrative that has been passed down through generations. In modern times, Andromeda symbolizes the spirit of exploration, representing humanity's desire to reach beyond the confines of our world and understand the universe. For amateur astronomers, Andromeda is often the first galaxy observed, a faint, glowing oval in the night sky that hints at the vastness beyond our solar system. For scientists, it is a treasure trove of data, offering insights into the processes that shape galaxies. And for dreamers and philosophers, it is a reminder of both our smallness and our potential, a symbol of the infinite possibilities that lie beyond our current understanding. Andromeda also challenges us to think about the possibility of life beyond Earth. With its trillion stars and countless planetary systems, the galaxy likely harbors an incredible diversity of worlds. Some of these planets may exist in the habitable zones of their stars, where conditions are suitable for liquid water and, potentially, life. While the vast distance between Earth and Andromeda makes direct exploration unlikely for now, future technologies may allow us to study its planets in greater detail, searching for signs of life or even civilizations. Carl Sagan, one of the greatest popularizers of science, often spoke of the interconnectedness of all things. He described galaxies like Andromeda as islands in the cosmic ocean, places of beauty and mystery that remind us of the unity of the universe. For Sagan, Andromeda was not just a distant galaxy, it was a reflection of our own existence and a reminder of the shared processes that have shaped the cosmos. Through Andromeda, we glimpsed the grandeur of the universe and the resilience of galaxies that have endured for billions of years. Its light, traveling across the void of space, carries a message of connection, discovery, and hope. It reminds us that while we may be small in the grand scheme of the universe, we are capable of great things, of looking beyond ourselves, of asking profound questions, and of reaching for the stars. The Andromeda Galaxy is more than a collection of stars and gas. It is a symbol of the infinite possibilities that await us, a testament to the power of curiosity and exploration. Its story is our story, a story of creation, growth, and transformation that spans billions of years. Through Andromeda, we are reminded of our place in the universe and the enduring spirit of humanity, a spirit defined by wonder, imagination, and the unyielding desire to explore the infinite. The conclusion about the Andromeda Galaxy cannot be captured solely through numbers or facts, for it represents something far greater, a timeless human quest to find our place in the universe. Its light, traveling millions of years across the vast expanse of space, connects us to the depths of the cosmos, reminding us that even at unimaginable distances, there are threads that bind us to this distant world. Andromeda is not just an astronomical object, it is a mirror reflecting our deepest questions about life, time, and infinity. It reminds us that every star, every atom within its structure, has undergone the same cycles of birth and destruction as the stars of our Milky Way. As Carl Sagan famously said, "We are made of star stuff," and Andromeda is a part of that shared story. The impending dance of Andromeda and the Milky Way is a symbol of cosmic motion, a never-ending process of mergers and transformations. It shows us that the universe is a place of constant change, where even majestic galaxies evolve, dissolve, and create new structures in their wake. For future generations who may witness these events, Andromeda will be not only an object of study but also a source of inspiration. It invites us to step beyond the familiar, to explore the unknown, and to reflect on the vast scales of time and space that far exceed our daily existence. And in the faint glow of this distant galaxy, we see not only its past but also our future, a future where humanity continues to gaze at the night sky, seeking answers to the profound questions that define our existence. Andromeda remains a symbol of hope, of reaching for the stars, and of humanity's unyielding drive to discover the infinite.